Welcome to this quiet space, a place for gentle stories and deep rest. Tonight, we will begin a journey together, a slow drift through the cosmos, exploring 100 relaxing facts about the universe. My hope is that as we travel through the vast and silent wonders of space, your mind will find a sense of peace, and your body will find the stillness it needs for a truly deep and restorative sleep. Before we begin our journey into the starlight, I would love to know where you are listening from tonight, or perhaps how your day was. Please feel free to leave a gentle comment below. Your presence here is deeply appreciated, and if you find comfort in our time together, please support this channel with a like and a subscription. Thank you so much. Let your body grow heavy now. Let your breath find its own slow rhythm, and allow the world outside to fade away. Our story begins not in the distant reaches of space, but right here, with you. Let your mind settle now, and let us begin with the most intimate of cosmic truths, a secret whispered in the very structure of your being. Every part of you, from the calcium that gives your bones their strength to the iron that gives your blood its life-sustaining crimson color, was forged in the heart of a star. You are, in the most literal and profound sense, made of stardust. Think of the quiet warmth you feel on your skin from the sunlight, a gentle cascade of energy from our own star, the sun. That warmth is a life-giving force, but it is also a reminder of the furnaces that created you. Long before our sun ever ignited, there were other stars, immense and ancient, scattered throughout the nascent Milky Way. Within their fiery cores, under pressures and temperatures that we can barely comprehend, the simplest elements in the universe, hydrogen and helium, were fused together in a patient, stellar alchemy. Over millions and millions of years, these stars burned, transforming light elements into heavier ones, creating carbon, the very backbone of life, nitrogen, which enriches our atmosphere and our DNA, oxygen, which you are breathing in this very moment. Each slow, deep breath you take is a connection to a star that died billions of years ago. Imagine it for a moment. A colossal, luminous sphere, floating in the silent darkness, tirelessly working, creating the very ingredients necessary for a future you were always destined to be a part of. The life of that star was a long and steady process of creation, and its legacy is now written in the language of your own body. This process is a part of a much grander, unending cycle, a cosmic recycling of the most beautiful kind. The atoms that currently form your hand, the one resting gently by your side, have been on a journey that stretches back across the eons. Before they were a part of you, they were part of the earth, perhaps locked within a stone or dissolved in the ocean. And before that, they were part of a vast, swirling cloud of interstellar dust and gas, a beautiful, ethereal nebula painted across the darkness of space. And before that, they were inside that star, participating in its brilliant life. And when that star reached the end of its existence, it did not simply vanish. It gave itself back to the universe. Depending on its size, it may have gently shed its outer layers, puffing them out into space like a celestial smoke ring, or it may have ended its life in a final, brilliant act of self-sacrifice. A supernova. Imagine this explosion not as a violent end, but as a moment of cosmic birth, a release. In that cataclysmic flash, brighter than 1 billion suns, the star scattered all the precious elements it had created far and wide, seeding the surrounding cosmos with the potential for new life. The very atoms that constitute you were once interstellar travelers, drifting on the silent winds of space for an unimaginable length of time, waiting to be gathered up again by gravity, to form a new star, a new planet, and eventually to find their way to you. You are not a fleeting creation, but a temporary arrangement of truly ancient and well-traveled matter. You are a collection of cosmic memories. And within that stellar explosion, an even more miraculous alchemy takes place. The immense energy of a supernova, or the even more spectacular collision of two ultra-dense neutron stars, is the only force in the universe powerful enough to create the heaviest of elements. The gold that we value for its beauty and rarity, the platinum and silver that we craft into heirlooms, all of these precious metals were born in the final, agonizing moments of a dying star. So the simple gold ring on a finger is not just a piece of metal. It is a relic of a cosmic cataclysm that occurred billions of years before the Earth was even formed. It is a piece of a star's heart, a tangible fragment of an explosion of unimaginable power, an artifact that has traveled across the galaxy to find its way into our world and our lives. When you think of a treasure, think of this. The universe, in its most violent and creative moments, forged these beautiful materials and then generously scattered them into the void, making them available for worlds that did not yet exist. We are the beneficiaries of this ancient, stellar generosity. The universe has adorned our small world with the remnants of its most spectacular events, leaving shimmering clues to its own powerful history, waiting for us to find them. This brings us to a deep and comforting law of the cosmos, the principle of the conservation of matter. It states that matter cannot be created or destroyed. It can only change its form. The atoms that make up your body right now have existed since the very early moments of the universe. They have been rearranged, reformed, and repurposed countless times, but they are, in essence, eternal. They have been the breath of a star, the dust of a nebula, the water of an ocean, the soil of a forest, and now they are you. And when your time as this unique and beautiful consciousness comes to a gentle close, those same atoms will be returned to the earth and to the universe, ready to continue their endless journey. They may one day become part of a leaf on a tall tree, or a drop of rain in a storm cloud, or perhaps, in the far distant future, they will be swept up into a new nebula to begin the cycle all over again, to form a new star in a galaxy yet to be born. There is no end, only transformation. You are a part of a continuous, unbroken chain of existence that stretches from the dawn of time to the furthest reaches of the future. You are not just a visitor in this universe. You are the universe itself, experiencing its own existence for one brief, wondrous moment. You are not just living in the universe is living within you. And this ancient matter, these star-born atoms, have combined in the most remarkable ways, forming the very liquid that cradles all life we know, the gentle substance of water. As you rest here, listening to the sound of my voice, consider the simple glass of water you might have by your bedside. It seems so ordinary, so familiar. Yet, within that clear, still liquid lies a history so profound it defies our everyday sense of time. A significant portion of the water on our planet, perhaps as much as half of the water in your body right now, is older than the sun itself. This water did not originate on Earth, nor was it created by our sun's warmth. Its story begins long before, in the vast, dark, and frigid expanse of the interstellar medium. Imagine a colossal cloud of gas and dust, many light years across, drifting silently in the Milky Way. This was the molecular cloud that would one day become our solar system. Within this freezing nebula, at temperatures just a few degrees above absolute zero, tiny grains of dust acted as gathering points, where stray atoms of hydrogen and oxygen could meet and bond, forming molecules of water ice. For millions upon millions of years, these microscopic ice crystals drifted in the darkness, part of a vast, pre-solar fog. They were there before the spark of our sun, before the planets began to form. So, the next time you feel the rain on your skin, or hear the gentle lapping of waves on a shore, remember that you are touching something truly ancient, a substance that has travelled from the cold heart of interstellar space to become the lifeblood of our world. This ancient, icy material from which our solar system was born did not all get used up in the formation of the sun and the planets. A vast repository of this primordial substance still exists, encircling our solar system in a distant, ghostly sphere known as the Oort cloud. It is almost impossible to picture its scale. Imagine our solar system, with the sun at the centre and the planets orbiting around it, as a single grain of sand in the palm of your hand. The Oort cloud, by comparison, would be a sphere more than a mile wide, with you standing at its centre. It is a vast, dark, and incredibly sparse shell of trillions of icy bodies, a silent, frozen halo marking the gravitational edge of our sun's kingdom. These are the leftovers from the birth of our solar system 4.5 billion years ago, kicked out to the furthest, coldest reaches by the gravitational pull of the giant planets. The Oort cloud is a place of profound stillness, a cosmic museum where the original building blocks of our world are preserved in a deep freeze. The objects within it drift in orbits that take millions of years to complete, in a darkness that is almost absolute. It is a gentle, silent reminder of our origins, a vast and unseen garden of ice, patiently circling our small sunlit home. From this distant and frozen reservoir, cosmic messengers have been sent to our world throughout its history. These messengers are the comets. Pushed by a passing star or a galactic tide, one of the icy bodies from the Oort cloud can be nudged from its ancient, stable orbit and begin a long, slow fall toward the inner solar system. As it gets closer to the sun, its ice begins to warm and sublimate, creating the beautiful, glowing coma and the long, ethereal tail that we see as a comet. In the early days of our planet, the Earth was a hot, dry, and barren rock. The leading theory is that a constant bombardment of these comets and water-rich asteroids over hundreds of millions of years delivered the water that would eventually form our oceans. Imagine the young Earth, shrouded in a primordial atmosphere, and look up to see not one, but dozens of these silent, graceful visitors streaking across the sky. They were not omens of destruction, but vessels of creation. Each impact was a gift, a cosmic delivery of the most precious substance in the universe. Our oceans, in a very real sense, are the result of a gentle, persistent rain of comets from the edge of the solar system, a slow and patient nurturing of our world by the cosmos itself. The vast blue that covers our planet is a memory of that ancient journey from the dark, cold void, and the existence of this water, in its life-giving liquid form, is a testament to the most delicate and improbable balance. Our Earth orbits the Sun within a region that astronomers call the habitable zone, or sometimes, more poetically, the Goldilocks zone. It is a narrow band of space where the conditions are not too hot and not too cold, but just right for liquid water to exist on a planet's surface. If the Earth were just a little closer to the Sun, its oceans would boil away into a thick, scalding atmosphere, like on Venus. If it were just a little farther away, the oceans would freeze into a solid shell of ice, encasing the world in a global glacier, like on Mars in its past. But here, in this perfect, slender orbit, our planet can host vast, liquid oceans, where the temperature is moderated and life can flourish. This delicate positioning, combined with the presence of our atmosphere which creates the right pressure, makes our world an incredibly rare jewel. While we now know that planets are common, worlds that can host liquid water on their surface may be few and far between. It is a reminder of the preciousness of our home, a planet held in a perfect, gentle equilibrium, allowing for the cosmic miracle of a flowing river, a deep blue sea, and the soft, quiet fall of rain that has lulled life on this planet to sleep for eons. Just as the water of our world travelled from a time before the sun, so too does the light that fills our night sky. Each point of light a silent messenger from a long-lost yesterday. When you gaze up into the velvet darkness, you are not seeing the stars as they are now, but as they once were, in a past as distant as their light is faint. This is because light, for all its incredible speed, is not instantaneous. It travels at a finite velocity, a cosmic speed limit of approximately 299,792 kilometers per second. While this seems unimaginably fast to us, the distances in the universe are so monumental that even at this speed, light takes time, sometimes a great deal of time, to cross the void. The sunlight that warms your face on a summer's afternoon left the sun a little over 8 minutes ago. If the sun were to suddenly vanish, we would continue to feel its warmth and see its light for 8 minutes, completely unaware that it was gone. This simple fact transforms the sky into the ultimate historical document. The moon we see is never the moon of this exact moment, but the moon as it was 1.3 seconds in the past. Every glance outwards is a glance backwards in time. The very act of seeing is an act of receiving a memory, a story told by light. This effect, this look-back time, becomes more and more profound as we look deeper into space. The closest star to our solar system, Proxima Centauri, is a little over 4 light-years away. This means the faint, reddish light we see from it tonight began its journey 4.24 years ago. When you see it twinkling, you are seeing the light of that star as it was when the world was a different place, when you were 4 years younger. The bright star Vega is 25 light-years away. Its light began traveling towards us a quarter of a century ago. The beautiful star cluster of the Pleiades, the Seven Sisters, shines with a light that is over 400 years old, light that left during the time of Shakespeare and Galileo. And when we look beyond the individual stars of our own galaxy to our nearest galactic neighbor, the great Andromeda galaxy, the light we see is 2.5 million years old. Let that sink in. The photons of light, the tiny particles of energy entering your eye from that faint fuzzy patch in the sky, started their immense journey across intergalactic space when our earliest human ancestors were first walking the plains of Africa. The universe was different then. The Earth was different. And yet, that light has traveled, unwavering, across all that time and all that space, to complete its journey in this very moment, in the quiet sanctuary of your awareness. The night sky is a tapestry woven from different eras, a collage of ancient histories, where some stars you see might not even exist anymore, having long since faded, their final light still racing towards us like a final, fond farewell. And we can look back even further, to a time before any stars or galaxies existed at all. Permeating every cubic centimeter of space, in every direction we look, is the oldest light in the universe. It is called the cosmic microwave background. It is the afterglow of the Big Bang itself. About 380,000 years after the universe began, it had cooled enough for the first atoms to form. At this moment, the universe, which had been a hot, dense, opaque fog, suddenly became transparent, and light was able to travel freely for the very first time. That first, brilliant flash of light has been traveling ever since. Over the course of 13.8 billion years, as the universe has expanded and cooled, this ancient light has stretched out, its wavelength growing longer and its energy diminishing, until today it is no longer visible light, but faint, cool microwaves, just a few degrees above absolute zero. You have encountered this light yourself. A tiny percentage of the static on an old, untuned television screen is interference from the cosmic microwave background. It is the faint, residual warmth from the dawn of creation, the universe's first breath made visible. It is the most ancient photograph possible, a gentle, pervasive hum that surrounds us completely, a constant, silent reminder of our ultimate origin. This cosmic speed limit, combined with the universe's finite age of 13.8 billion years, creates a natural boundary to our vision. This boundary is called the observable universe. It is not a physical wall or an edge to space, but rather a temporal horizon. Since the universe is 13.8 billion years old, we can only see objects whose light has had 13.8 billion years or less to reach us. Any galaxy or star that lies beyond this horizon is, for now, invisible to us. Its light still on its long journey through the expanding cosmos. This creates a personal bubble of perception for us, a sphere with Earth at its center, encompassing everything we can possibly see. And what is profoundly beautiful is that if there were an observer in a galaxy 10 billion light-years away, they would have their own overlapping sphere of the observable universe, and from their perspective, they would be at the center. Every point in the cosmos is the center of its own observable universe. This doesn't make us feel small, but rather, it connects us. We each have our own unique window into the grand history of the cosmos, a horizon of light and time that defines our place in the grand expanse. The simple, peaceful act of looking up at the night sky is a deep and silent communion with this history, a conversation with the past carried on the gentle, ancient waves of light. And this ancient light, on its immense journey across the eons, does not travel through a perfectly flat and empty void. Its path is gently guided, bent, and shaped by an invisible and elegant presence that weaves through the very fabric of the cosmos itself. This presence is gravity. For centuries, we imagined gravity as a mysterious, instantaneous force, a kind of invisible rope pulling objects toward one another. But Albert Einstein offered a far more beautiful and profound picture with his theory of general relativity. He proposed that space and time are not separate entities, but are woven together into a single, four-dimensional fabric, space-time. And what we perceive as gravity is nothing more than the curvature of this fabric. Imagine a vast, taut rubber sheet. If you place a heavy bowling ball in its center, the sheet will sag and warp. This is what massive objects like stars and planets do to space-time. They create a gentle depression, a curve in the cosmic fabric around them. Now, if you roll a smaller marble nearby, it won't be pulled toward the bowling ball by a mysterious force. Instead, it will simply follow the curve in the sheet, circling the depression in a smooth, continuous orbit. This is what our Earth is doing right now. It is not being pulled by the sun. It is rolling, peacefully, through the valley in space-time that the sun has created. Gravity is not a force. It is the geometry of the universe, the silent architecture that gives the cosmos its shape and its motion. This elegant bending of space-time does not just affect the motion of planets, it also affects the path of light itself. As a beam of light from a distant galaxy travels towards us, it too must follow the curves and contours of the space-time fabric. If it passes by a very massive object, like another galaxy or a huge cluster of galaxies, its path will be noticeably bent, much like how a glass lens bends light. This phenomenon is known as gravitational lensing, and it provides some of the most stunningly beautiful and surreal images in all of astronomy. Sometimes, the gravity of a foreground galaxy cluster can act as a natural telescope, a cosmic magnifying glass, bending and focusing the light from a much more distant galaxy behind it. When we look at such a cluster, we can see the light from the background galaxy smeared into beautiful, ghostly arcs and rings of light, known as Einstein rings. In some cases, the light is bent in such a way that we see multiple images of the same distant galaxy surrounding the foreground lens. It is a breathtaking spectacle, the universe itself revealing its hidden depths to us. It allows us to see objects that would otherwise be too far away and too faint to detect, all because gravity, in its silent elegance, has chosen to bend their ancient light and guide it towards us. This understanding of orbits as a path through curved space-time offers a deeply peaceful perspective on our own planet's journey. The Earth, in its year-long voyage around the Sun, is not fighting against a constant pull or expending any energy to maintain its orbit. It is in a state of perfect, continuous, free fall. It is simply following the straightest possible line through a curved universe. Imagine walking along a line of longitude on the Earth's surface. From your perspective, you are walking in a perfectly straight line, but because you are on a curved surface, your path will eventually bend and meet back where it started. The Earth is doing the same thing in 4 dimensions. It is coasting. It is flowing. Its motion is effortless, a graceful and silent dance with the geometry of the solar system. For the last 4.5 billion years, our planet has been engaged in this serene, perpetual ballet, held not by a forceful tether, but by a gentle, geometric embrace. It's a comforting thought that our world's ceaseless journey is not a struggle, but a state of perfect, harmonious equilibrium with the fundamental structure of the cosmos. And sometimes, the most cataclysmic events in the universe can send shivers through this cosmic fabric. When 2 truly massive objects, like 2 black holes or 2 neutron stars, spiral into each other and merge, they create a disturbance in space-time so profound that it propagates outwards in all directions, just like the ripples on a pond when you toss in a stone. These are gravitational waves. They are not waves of light or matter traveling through space. They are ripples in the very fabric of space-time itself. As a gravitational wave passes by, it gently stretches and compresses everything in its path, including you. The effect is so infinitesimally small, far smaller than the width of a single atom, that for 100 years after Einstein predicted them, they remained purely theoretical. But in 2015, we finally built instruments sensitive enough to detect them. We can now hear the echoes of these distant, cosmic collisions. Imagine, 1 billion light-years away, 2 black holes merged, releasing more energy in a fraction of a second than all the stars in the observable universe combined. And that ancient, powerful event sent a whisper across space-time, a ripple so faint that it took all of our ingenuity to perceive it. We have opened a new sense with which to experience the cosmos, a way to listen to the silent, gravitational symphony played by the universe's most majestic and mysterious objects, all held within gravity's gentle, persistent, and all-encompassing embrace. This silent, gravitational embrace, acting over billions of years, has gathered hundreds of billions of stars, vast clouds of dust, and unseen matter into the breathtaking structure we call home. A luminous, spinning island in the void, the Milky Way galaxy. From a great distance, if we could look down upon it, we would see a magnificent spiral, a vast, glittering pinwheel of light turning slowly in the silent darkness. At its heart lies a dense, glowing sphere called the central bulge, a tightly packed city of ancient, golden stars. Extending from this brilliant core are the great spiral arms, rivers of light that curve outwards into the void. These arms are the bustling, youthful neighborhoods of our galaxy, where vast, ethereal clouds of pink and crimson gas, the stellar nurseries are collapsing to give birth to brilliant, hot new stars, which shine with a fierce, bluish-white light. Surrounding this entire flat disk is a vast, ghostly sphere known as the halo, a sparse and immense realm containing the galaxy's oldest, most primitive stars, and great unseen clouds of mysterious dark matter. Our galaxy is not a random scattering of stars, but a place of profound structure and beauty, a cosmic metropolis with a glowing heart, vibrant suburbs, and a vast ancient countryside, all turning together in a slow, cosmic ballet that takes hundreds of millions of years to complete. One turn. Our own place in this grand city of stars is one of remarkable peace and stability. Our sun and its family of planets do not reside in the chaotic and densely packed galactic core, where radiation levels are high and the gravitational tides of countless neighboring stars would disrupt our solar system. Nor do we live in the sparse, distant outer reaches of the halo, where the elements heavier than hydrogen and helium, the very stardust necessary to build rocky planets and living beings, are scarce. Instead, we are nestled within a smaller, partial spiral arm known as the Orion Arm, about 27,000 light-years from the galactic center, roughly two-thirds of the way out to the visible edge. We live in the galactic equivalent of a quiet, peaceful suburb. Here, the stars are spaced far enough apart to give us stability, yet the interstellar medium is rich enough in recycled stellar material to have allowed for the formation of a world like ours. It is a profoundly fortunate location, a place where life has been given the long, uninterrupted eons it needed to blossom, shielded from the violent activity of the galactic core, and nourished by the gentle abundance of our stellar neighborhood. This ideal positioning has led astronomers to define a concept known as the galactic habitable zone. Much like the habitable zone around a star where liquid water can exist, the galactic habitable zone is a ring-shaped region within a galaxy that is considered the most favorable for the development of complex life. This zone is a delicate compromise. It must be far enough from the galactic center to avoid the intense radiation from the central black hole and the frequent, disruptive supernovae of a dense star field. Yet, it must be close enough to the galaxy's richer regions to have a high enough concentration of heavy elements, the cosmic metals forged in stars, which are the essential building blocks of terrestrial planets and the chemistry of life. Our solar system lies comfortably within this gentle, life-sustaining ring of the Milky Way. It is a beautiful thought, a series of nested sanctuaries. We live on a planet in the habitable zone of our star, which in turn orbits within the habitable zone of our galaxy. It speaks to a universe where the conditions for life, while perhaps rare, are the result of a profound and delicate balance on multiple, magnificent scales, a cosmic serendipity that has made our existence possible. And at the very heart of our vast, spinning galaxy, the gravitational anchor point around which everything we see makes its long and graceful journey, lies a mystery. This anchor is a supermassive black hole, named Sagittarius A star. Its mass is more than 4 million times that of our Sun, all contained within a region smaller than the orbit of Mercury. Yet, from our vast distance, it is not a terrifying monster or a cosmic vacuum cleaner. It is a point of immense, quiet gravity. Its influence, so far from the core, is gentle and stable, providing the central pivot for the galaxy's majestic rotation. Every 230 million years, our solar system completes one grand orbit, one galactic year, around this silent, unseen heart. We are all on this journey together, every star and every nebula in our galactic disk, participating in this slow, collective pirouette. It is a humbling and connecting thought to feel yourself a part of this immense, shared motion. A tiny boat drifting on a vast, shimmering river of stars as it flows in a great, silent circle around the tranquil, dark center of our luminous island in the void. And as we drift on this great, shimmering river of stars, we become aware that the luminous galaxy we see, this city of light, is only a fraction of what is truly there. The vast majority of our galaxy, and indeed the entire universe, is made of a mysterious, unseen substance, a ghostly presence that does not shine or reflect light, but which we can feel through its immense gravitational pull. This is dark matter. For decades, astronomers noticed something strange about galaxies like ours. When they measured the speed of the stars orbiting the galactic center, they found that stars on the outer edges were moving far too quickly. Based on the amount of visible matter, the stars, gas, and dust, we could see these fast-moving outer stars should have been flung off into intergalactic space long ago. The galaxy was spinning so fast it should have torn itself apart. The only way it could hold together is if it contained far more mass, and therefore far more gravity, than we could account for. Imagine a spinning merry-go-round. The horses on the outside edge naturally move slower than those closer to the center. But if you saw a merry-go-round where all the horses, from the center to the edge, were moving at nearly the same speed, you would know something invisible and heavy must be spread throughout the entire structure, holding it together. This is our galaxy. Dark matter is this unseen weight, a vast, invisible halo of substance that envelops our Milky Way. Its gentle, persistent gravity providing the extra glue needed to keep our cosmic city from flying apart. This invisible substance is not just confined to individual galaxies. It appears to be the underlying scaffolding of the entire universe. On the largest possible scales, cosmologists have discovered that galaxies are not distributed randomly throughout space. Instead, they are arranged in a vast, intricate, and beautiful pattern. A luminous network of filaments, clusters, and great empty voids that has come to be known as the cosmic web. Computer simulations show that this structure is a direct result of the gravity of dark matter. Over billions of years, the gentle, persistent pull of dark matter has herded ordinary matter into these long, interconnected filaments, much like how water beads up and runs along the threads of a spider's web. The galaxies we see, these brilliant islands of light, are like shimmering dewdrops that have condensed along the invisible threads of this cosmic structure. So when we look out at the grand tapestry of galaxies, we are only seeing the illuminated pattern, the visible embroidery on an immense, unseen fabric. The universe has a hidden architecture, a silent, gravitational framework that has guided the formation of everything we can see, and we are only just beginning to perceive its true shape. As if one cosmic mystery were not enough, astronomers in the late 1990s discovered another. They were trying to measure the rate at which the expansion of the universe was slowing down due to gravity. But they found the exact opposite. The expansion of the universe is not slowing down, it is accelerating. Some strange, repulsive force is acting against gravity, pushing galaxies apart at an ever-increasing rate. This unknown influence has been named dark energy. Unlike dark matter, which clumps together gravitationally, dark energy seems to be a smooth, uniform property of space itself. It is a kind of intrinsic energy of the vacuum, a gentle, persistent pressure that is causing the fabric of space-time to expand. This creates a beautiful and profound cosmic tension. Throughout the universe, the gentle inward pull of dark matter's gravity is working to build structures, stars, galaxies, and clusters, while the gentle, outward push of dark energy is working to expand the space between them. For now, on the scale of a galaxy, dark matter's gravity wins, holding us together. But on the largest scales, the inexorable push of dark energy is the dominant force, determining the ultimate fate of our cosmos. It is like a quiet, deep breath that the universe is taking, an exhalation that will continue, slowly and peacefully, forever. When we put all of this together, we arrive at a conclusion that is both humbling and deeply awe-inspiring. If we were to take an inventory of all the matter and energy in the universe, we would find that the ordinary matter, the stuff of stars, planets, trees, and us, every atom that we can see and touch makes up only about 5% of the total. About 27% of the universe is the invisible scaffolding of dark matter, and the vast majority, a staggering 68%, is the mysterious, accelerating force of dark energy. This means that for all of our scientific progress, for all the beauty we can see through our telescopes, we have only perceived a tiny fraction of what the universe truly is. 95% of reality remains a deep and profound mystery. We are floating in a vast, dark ocean, and the luminous specks of light we call galaxies are like the beautiful, bioluminescent fish swimming within it. But the true nature of the water itself, the very substance of this cosmic ocean, remains almost entirely unknown to us. A silent, invisible presence that hints at a universe far stranger and more wonderful than we have ever dared to imagine. And this vast, dark ocean of the cosmos, which seems so empty to our eyes, is itself a place of profound and subtle activity. The vacuum of space, the silence between the stars, is not a void of perfect nothingness, but a shimmering, energetic sea, an empty fullness whose existence is one of the deepest truths of modern physics. On the scale of our everyday lives, space-time appears smooth, continuous, and calm, like the placid surface of a vast, still lake seen from a great height. But if we could zoom in, down to the impossibly small dimensions of the quantum realm, a scale trillions of times smaller than an atom, that smooth surface would resolve into a chaotic, bubbling turmoil. This is the realm of quantum foam. On this fundamental level, space-time is not placid at all. It is a roiling, unpredictable froth of energy, a constant tremor at the very foundation of reality, where concepts like here and now begin to lose their meaning. It is a world where the geometry of the universe is constantly fluctuating in a wild, energetic dance that is forever hidden from our direct perception, yet underpins everything that is. This energetic dance of the vacuum is not just an abstract idea, it is populated by a constant fizz of ghostly particles. According to the laws of quantum mechanics, space is never truly empty. It is always simmering with what are known as virtual particles. These are pairs of particles and their antimatter counterparts that spontaneously leap into existence, borrowing a tiny amount of energy from the vacuum itself. They exist for an infinitesimal fraction of a second, a fleeting moment allowed by the universe's uncertainty principle, before they find each other and annihilate, returning their borrowed energy to the void. This is happening constantly, everywhere, at every moment. The empty space around you right now is a seething cauldron of these phantom births and deaths. Imagine it as the quiet, steady breath of the universe, a silent hum of potential that fills all of existence. These fleeting particles are not just a curiosity, they are essential to the workings of the universe. They are the messengers that carry the fundamental forces of nature. The electromagnetic force, for example, is communicated across empty space by the exchange of virtual photons. The silent, empty void is, in fact, the very medium that allows the universe to communicate with itself. This strange idea of an energetic vacuum is not just a theory. It produces a real, measurable physical force. This is known as the Casimir effect. Imagine taking two perfectly smooth, uncharged metal plates and placing them incredibly close together in a perfect vacuum, just a few nanometers apart. The quantum vacuum outside the plates is teeming with virtual particles of all possible wavelengths and energies. But between the two plates, only the virtual particles with very short wavelengths, those that can fit neatly into the tiny gap, are able to pop into existence. The longer wavelength particles are excluded. This means there are more virtual particles, and thus more energy and pressure, in the space outside the plates than in the space between them. The result is a net force that gently, but inexorably, pushes the two plates together. This is a physical force, born from nothing but the structure of the vacuum itself. It is a profound and beautiful demonstration that the void is not empty. It is an active and powerful component of our reality, a silent sea of energy that can move and shape the physical world in subtle, yet undeniable ways. As we zoom back out from the quantum realm to the cosmic, we find that even the vast stretches of space between the stars are not a perfect vacuum. This region, known as the interstellar medium, is a far better vacuum than anything we could hope to create in a laboratory on Earth, but it is not truly empty. It is filled with a tenuous, almost ethereal fog of gas, primarily single atoms of hydrogen and helium, along with tiny, microscopic grains of dust made of carbon and silicates. The density is so low that on average, you might only find one atom in every cubic centimeter of space, meaning an atom might travel for meters before encountering a neighbor. It is a realm of profound silence and isolation. And yet, it is within this vast, near-empty space that the seeds of future creation lie dormant. It is this very gas and dust that gravity, over the course of millions and millions of years, will patiently gather together, slowly coaxing it into the vast, beautiful, and dense clouds we call nebulae. The interstellar medium, this great emptiness, is in truth the fertile soil of the galaxy, the womb from which all future generations of stars and planets will eventually be born. There is no true nothingness to be found, only the quiet, patient potential for everything to come. And from this vast and tenuous interstellar medium, this womb of silent potential, gravity can gather matter together, patiently, over eons, until it collapses into stars. And when the most massive of these stars end their lives, they can create objects of such incredible density and energy that they challenge the very limits of our understanding. The celestial jewels known as neutron stars. Their story begins in the heart of a supernova. When a star more than 8 times the mass of our Sun runs out of fuel, its core collapses catastrophically under its own immense gravity. The outer layers of the star are blasted outwards in one of the most brilliant and violent events in the universe, an explosion that can briefly outshine an entire galaxy. But in the silent, still center of this cosmic cataclysm, a miracle of compression takes place. The collapsing core, which might still contain more mass than our entire Sun, is crushed down with such unimaginable force that the very structure of its atoms is destroyed. Protons and electrons are squeezed together to form a sea of pure neutrons. From the fiery death of a stellar giant, something entirely new is born. A single, city-sized, atomic nucleus floating in the quiet aftermath of the explosion. The defining characteristic of a neutron star is its almost incomprehensible density. The process of its birth squeezes a mass greater than our Sun's into a sphere only about 20 kilometers, or 12 miles, across. It is an entire star compressed to the size of a city like Manhattan or London. To try and grasp this, imagine a single sugar cube of neutron star material. That tiny cube would have a mass of about 100 million tons. A single teaspoon of it, brought to Earth, would weigh several billion tons, as much as a mountain. It is a state of matter so dense that it is second only to a black hole. The gravity on its surface is hundreds of billions of times stronger than Earth's. The object itself is a near-perfect sphere, its immense gravity crushing any surface irregularities, making it one of the smoothest objects in the universe. It is a piece of cosmic alchemy, matter transformed into a state so extreme, so alien, that it pushes our physical theories to their breaking point. It is a silent testament to the awesome, transformative power of gravity. Many of these incredible objects are also spinning at phenomenal speeds, a consequence of the conservation of angular momentum from their parent star's collapse, like an ice skater pulling in their arms to spin faster. Some neutron stars rotate hundreds of times every single second. These rapidly rotating neutron stars are also intensely magnetized, and they emit powerful beams of radiation from their magnetic poles. As the star spins, these beams of energy sweep across the cosmos, like the beam of a celestial lighthouse. If one of these beams happens to sweep across the Earth, our radio telescopes detect a brief, regular pulse of energy. For this reason, these objects are known as pulsars. The regularity of their pulses is astonishing, making them the most accurate and stable clocks known in the universe. Their rhythmic signals, ticking away across thousands of light-years of space, are so precise that they allow us to test the laws of physics in extreme environments we could never replicate, turning these exotic stellar remnants into cosmic laboratories. They provide a steady, rhythmic heartbeat in the vast silence of the galaxy. And among this already extreme family of objects, there exists an even more exotic type known as a magnetar. A magnetar is a neutron star with a magnetic field of truly mind-boggling power. Its magnetic field is typically 1,000 times stronger than that of an ordinary neutron star, and trillions of times stronger than the magnetic field of our own Earth. It is the most powerful magnetic field we know of in the entire universe. This field is so intense that it would be lethal to a human from 1,000 kilometers away, and it could strip the data from every credit card on Earth from a distance of halfway to the moon. The immense magnetic stresses on a magnetar's surface can sometimes cause its crust to crack, creating a starquake. These events release colossal bursts of energy in the form of X-rays and gamma rays, flashes of high-energy light, so powerful they can be detected clear across our galaxy. These objects, the neutron stars, pulsars, and magnetars, are the universe's diamonds. They are forged in the fiery pressure of a star's death, compressed into a form of exquisite density and power, and sometimes they shine across the cosmos with a brilliant, rhythmic, and unwavering light. These cosmic diamonds, the neutron stars, represent matter compressed to its absolute limit, a state where neutrons are packed shoulder to shoulder. But if the core of a dying star is massive enough, even the immense strength of these neutrons cannot withstand the final, crushing victory of gravity, and the collapse continues, on and on, with nothing to stop it. The core continues to shrink until its entire mass is concentrated into an infinitely dense point called a singularity, creating an object that warps spacetime so profoundly that it tears a hole in the universe itself. A black hole. The most defining feature of a black hole is not a physical surface, but an invisible boundary known as the event horizon. This is not a wall or a membrane, but rather a threshold of no return. It is the precise distance from the singularity where the gravitational pull becomes so strong that the escape velocity exceeds the speed of light. Imagine a river that flows faster and faster as it approaches a great waterfall. The event horizon is like a line in the water, where the current becomes so powerful that even the fastest boat, in this case, a particle of light, cannot turn back. There is nothing dramatic about crossing it. An astronaut falling through the event horizon would notice nothing special in that exact moment. The crossing would be peaceful, silent, and utterly final. It is a one-way door into a region of space-time from which no information, no light, no echo can ever return. One of the most mind-bending consequences of gravity's effect on space-time is its effect on time itself. This is known as gravitational time dilation. The stronger the gravitational field, the slower time flows. This effect is real and measurable. Even here on Earth, clocks on satellites in orbit, where gravity is weaker, tick slightly faster than clocks on the ground. Near the event horizon of a black hole, this effect becomes extreme. If you were in a spaceship, safely orbiting a black hole from a great distance, and you were watching a friend's ship fall towards it, a strange thing would happen. You would see their clock begin to tick slower and slower relative to your own. Their movements would appear to slow down. The light from their ship would become stretched and shifted towards the red end of the spectrum. As they got closer and closer to the event horizon, their ship would seem to slow to a near-complete stop, taking an infinite amount of your time to make that final crossing. You would never actually see them fall in. You would only see their image grow dimmer and redder, frozen for an eternity at the edge of the abyss, until they faded away into nothing. The event horizon is a place where time, from an outside perspective, gently stretches to a standstill. While the crossing of the event horizon itself might be tranquil, the journey there can be hazardous, depending on the size of the black hole. This is due to the extreme tidal forces in its vicinity. The force of gravity weakens with distance. So for an object falling feet first into a relatively small stellar mass black hole, the gravitational pull on its feet would be exponentially stronger than the pull on its head. This immense difference in gravitational force would stretch the object vertically while compressing it horizontally, a process that has been given the wonderfully descriptive name of spaghettification. However, for the supermassive black holes that reside at the centers of galaxies, objects that are millions or billions of times the mass of the Sun, the story is different. Because their event horizons are so much larger, the gradient of their gravity is much gentler at the edge. An object could fall through the event horizon of a supermassive black hole without being torn apart by these tidal forces, only meeting its end much later, deep within. This helps to paint a more nuanced picture of these cosmic enigmas. They are not all violent destroyers, but a diverse population of objects whose effects depend greatly on their scale. For a long time, black holes were thought to be truly eternal prisons, the final resting place for any matter or light that fell inside. But the great physicist Stephen Hawking, by combining the laws of general relativity with quantum mechanics, discovered something extraordinary. He theorized that due to quantum effects involving virtual particles near the event horizon, black holes are not completely black. They should emit a faint, continuous stream of thermal radiation, which has become known as Hawking radiation. This process is unbelievably slow. A black hole the mass of our Sun would take far longer than the current age of the universe to completely evaporate. But the theory implies that black holes are not eternal. They have a finite lifespan. They have a faint temperature, and they have a soft, almost imperceptible glow. This transforms them from simple voids of destruction into dynamic, albeit incredibly patient, participants in the cosmic cycle. They are like deep, slow breaths in the life of the universe. Over unimaginable timescales, they will gently sigh their stored energy back out into the cosmos, until finally, in the far, distant twilight of the universe, the last black hole will whisper its last particle of radiation and peacefully fade away. And while these black holes represent the universe in its most silent and enigmatic state, the cosmos is also filled with a brilliant chorus of light. And within this light, within the simple colors of the stars, is a hidden language that tells us the story of their lives, their composition, and the very elements that make us who we are. If you take the light from a single star and pass it through a prism, it will spread out into a familiar rainbow of colors, a spectrum. But when astronomers look closely at this stellar rainbow, they find it is not perfectly smooth. It is crossed by a series of thin, dark lines. These lines are like a cosmic barcode, a unique fingerprint left on the light by the chemical elements in the star's atmosphere. Each element, hydrogen, helium, iron, calcium, absorbs light at its own specific set of wavelengths, leaving a dark gap in the spectrum. This technique is called spectroscopy, and it is one of the most powerful tools in astronomy. It allows us to know, with incredible precision, what a star is made of, even though it may be trillions of miles away. It is how we know that the Sun is mostly hydrogen and helium. It is how we know that we are made of the same elements as the stars. It is a beautiful and intimate connection, the ability to read the chemistry of a distant, fiery orb simply by paying close attention to the message it sends us on its gentle waves of light. The overall color of a star's light tells an even simpler, more immediate story, the story of its temperature. Just as a piece of metal in a blacksmith's forge will first glow a dull red, then a brighter orange, and finally a brilliant blue-white as it gets hotter, so too do stars shine in different colors, based on their surface temperature. The coolest stars in the sky are the red dwarfs and red giants, with surface temperatures of only a few thousand degrees. They shine with a soft, gentle, ruby-colored light, like the fading embers of a cosmic fire. Stars like our own Sun, with a medium surface temperature of around 5,500 degrees Celsius, glow with a bright, cheerful yellow-white light. And the hottest, most massive, and youngest stars in the universe shine with a brilliant and intense blue-white light, their surfaces blazing at tens of thousands of degrees. This simple fact turns the night sky into a vast visual thermometer. The rich tapestry of stellar colors is a direct map of the different ages, masses, and energies of the stars around us. The sky is not just a collection of white dots. It is a vibrant canvas, painted with a palette of cosmic fire, from the cool ancient reds to the hot, youthful blues. This language of light also tells us about motion. You have likely experienced the Doppler effect with sound. The pitch of an ambulance siren sounds higher as it races towards you, and then drops to a lower pitch as it races away. Light behaves in a similar way. If a star is moving towards us, its light waves get compressed, shifting its entire spectrum and its fingerprint of absorption lines slightly towards the blue end of the rainbow. This is called a blue shift. If a star is moving away from us, its light waves get stretched out, shifting its spectrum towards the red end. This is called a redshift. In the 1920s, the astronomer Edwin Hubble made a monumental discovery. He found that the light from almost every distant galaxy was redshifted, and the farther away a galaxy was, the more its light was redshifted, meaning the faster it was moving away from us. This was the first direct evidence that our universe is not static, but is expanding. The redshift of distant galaxies is the visual signature of this grand, cosmic expansion, the universe's own motion written in the subtle shifting of ancient light. Sometimes, the universe uses a color palette that is impossible to replicate here on Earth. When we look at photographs of beautiful, glowing nebulae, the vast clouds of gas and dust where new stars are forming, we often see a distinct and ethereal greenish hue. This light is produced by oxygen atoms, but it is a type of light that has been called forbidden. This is because it is created by a quantum transition within the oxygen atom that is so slow and so unlikely to happen, it can only occur in the near-perfect vacuum of deep space. Here on Earth, atoms are constantly jostling and colliding with one another, millions of times per second, which disrupts this delicate process. But in the vast emptiness of a nebula, an oxygen atom can float undisturbed for minutes or even hours, giving it the time it needs to release this specific, ghostly, green photon of light. This forbidden light is a message from the void itself. It is a color that can only be painted on the vast, silent canvas of the cosmos, a whisper from the patient heart of the interstellar medium, telling a story of serene and beautiful emptiness. This story of motion, written in the shifting colors of starlight, reveals a universe that is far from static. Galaxies themselves are not fixed islands in the void, but are engaged in a slow, silent, and immense dance, a gravitational ballet choreographed over billions of years that sometimes leads them to merge and collide in the most creative of cosmic events. The great spiral galaxies we see today, including our own Milky Way, were not born in their current majestic form. They were built up gradually, over the course of cosmic history, through a process of hierarchical merging. They grew by absorbing, or cannibalizing, countless smaller dwarf galaxies that strayed too close. This process is not a violent crash in the way we might imagine a collision on Earth. The distances between individual stars are so incomprehensibly vast that when two galaxies merge, the chances of any two stars actually colliding are practically zero. Instead, the two great cities of stars pass through each other like ghosts, their stellar populations intermingling as their orbits are bent, twisted, and reshaped by their combined gravitational fields. It is a gentle, flowing process of integration, a silent and graceful intermingling that unfolds over hundreds of millions of years. While the stars themselves glide past one another, the true creative action in a galaxy merger happens within the vast, diffuse clouds of interstellar gas and dust. As the two galaxies swirl together, these immense clouds, which are the raw material for future stars, are violently compressed and churned. This compression triggers a massive, galaxy-wide wave of star formation, an event known as a starburst. The merging galaxies light up with a furious, brilliant burst of creation. Across the swirling, chaotic landscape of the collision, countless new stars ignite, shining with the brilliant blue light of cosmic youth, and the surrounding gas clouds glow with the characteristic pink and crimson hues of stellar nurseries. The galactic collision becomes a crucible of renewal. It is a cosmic fireworks display of unimaginable scale and duration, transforming the two separate, aging galaxies into a single, younger, and more vibrant entity. These mergers are one of the universe's most powerful engines of change and rebirth, a beautiful and dramatic reminder that even on the grandest scales, the cosmos is in a constant state of evolution and transformation. This process of galactic merging is not just something that happens in the distant universe. It is a part of our own cosmic future. Our Milky Way galaxy is currently on a collision course with its nearest large neighbor, the Andromeda Galaxy. Traveling towards each other at a speed of over 100 kilometers per second, the two galaxies are destined to begin their grand merger in about 4.5 billion years. By that time, our Sun will have become a red giant, and the Earth will likely no longer be habitable. But if there were any observers to witness the event, they would be treated to a celestial spectacle of breathtaking beauty. Slowly, over the course of millions of years, the night sky would begin to change. The faint, fuzzy patch of Andromeda would grow larger and brighter, resolving into individual stars, until the sky was filled with a second, brilliant river of light, a celestial tapestry woven from two galaxies. Eventually, after a long and intricate dance, the two spirals would merge into a single, even larger galaxy, a new metropolis of stars that astronomers have already provisionally named Milkomeda. It is a vision of our own galaxy's destiny, a serene and beautiful transformation that awaits in the deep future. And as we look closely at our own Milky Way, we can see the gentle echoes of its past collisions. When a large galaxy like ours absorbs a much smaller dwarf galaxy, the immense tidal forces of the larger galaxy stretch the smaller one apart, pulling it into long, flowing ribbons of stars. These ghostly structures are known as tidal streams. Astronomers have been able to map dozens of these faint, river-like streams of stars arcing through our galaxy's halo. Each one, the remnant of an ancient galaxy that was consumed by the Milky Way billions of years ago. These stellar streams are a form of galactic archaeology. They allow us to trace the history of our home galaxy, revealing the building blocks from which it was assembled. They are like faint, beautiful scars, the gentle memories of past encounters, painting a silent and elegant picture of our galaxy as a living, breathing, and ever-growing entity shaped by the gentle and persistent dance of gravity. And in these great bursts of creation, these cosmic nurseries lit up by galactic collisions, countless new suns ignite. And for a long time, we could only wonder if these suns were solitary wanderers, or if they, like our own, were the centers of their own families of worlds. We now know that where there are stars, there are almost always planets, a vast and unseen population of worlds orbiting other suns, which we call exoplanets. For centuries, these worlds existed only in the realm of philosophy and speculation, as they are far too small, too dim, and too close to their brilliant host stars to be seen directly with our telescopes. But in recent decades, astronomers have devised ingenious, indirect methods to find them, turning the search for alien worlds from a dream into a scientific reality. The most successful of these is the transit method. It requires a great deal of patience and a little bit of luck. A space telescope will stare, unblinking, at a patch of thousands of stars, measuring their brightness with incredible precision. If a planet happens to be orbiting one of those stars, and its orbit is aligned just right so that it passes in front of the star from our point of view, it will block a tiny fraction of the starlight, causing a minute, periodic dip in the star's measured brightness. It is like detecting the shadow of a gnat flying in front of a searchlight from hundreds of miles away. But from that faint, fleeting dimming, we can infer the presence of an entire world, its size, and how long it takes to orbit its sun. Another wonderfully subtle technique for finding these hidden worlds is the radial velocity method, sometimes called the wobble method. Just as a star's gravity holds a planet in orbit, the planet's own tiny gravity pulls back on the star. This causes the star to execute its own small counter-orbit, a slight wobble as its unseen companion circles it. We can detect this gentle, rhythmic dance even from light years away. As the star wobbles towards us in its tiny orbit, its light is slightly compressed, shifting towards the blue end of the spectrum. As it wobbles away from us, its light is stretched, shifting towards the red. By observing these minuscule, periodic shifts in the star's light, we can detect the gravitational whisper of the planet. We cannot see the world itself, but we can see the effect of its quiet, gravitational presence on its parent star. It is a beautiful way of seeing the unseen, detecting the existence of a hidden partner in a cosmic ballet, by watching the graceful motion of the star it leads. Through this and other methods, we have now confirmed the existence of thousands of exoplanets in our corner of the galaxy. The discoveries that have poured in have revealed a universe far more creative and diverse in its planet-making than we ever imagined. Our own solar system, with its small, rocky inner planets and large, gaseous outer planets, is just one possible arrangement among countless others. We have found hot Jupiters, huge gas giants orbiting so close to their parent stars that their years last only a few Earth days, their atmospheres scorched to thousands of degrees. We have discovered super-Earths, planets that are larger and more massive than Earth, but are still primarily rocky in their composition. There are water worlds, potentially covered in a single, globe-spanning ocean, thousands of miles deep. There are planets orbiting two suns, where you might see a double sunset every evening. The universe is a grand laboratory of planetary formation, and it has produced a veritable zoo of strange and wonderful worlds that challenge our neat classifications and expand our sense of what is possible. The sky above us is not just filled with stars, it is filled with solar systems, each with its own unique story and its own family of remarkable worlds. Of all these discoveries, perhaps the most exciting is the search for planets that are like our own. The ultimate goal for many astronomers is to find an Earth-sized, rocky planet orbiting within its star's habitable zone, that Goldilocks region where temperatures are just right for liquid water to exist on the surface. We have now found many such worlds. Planets like Kepler 186f, or the 7 Earth-sized worlds orbiting the nearby star TRAPPIST-1. We do not yet know if these planets have atmospheres, or if they have water, or if they harbour life. But their discovery has transformed our perspective on the cosmos. For the first time in human history, we can point to other stars in the sky and say with confidence, that star has a planet that could be like ours. It fills the cosmos not with certainty, but with a profound and quiet sense of potential. Each star in the night sky is no longer just a distant point of fire, but a potential sun, the possible anchor of an unseen family of worlds, some of which may be just as gentle, just as beautiful, and just as full of life as our own precious Earth. This vast and growing catalogue of worlds, discovered as faint shadows and gravitational whispers, invites us to wonder, what would it be like to stand on these distant shores? While we cannot yet see their landscapes, our instruments can begin to decipher the nature of their atmospheres, revealing climates and conditions so alien they sound as if they are drawn from myth or science fiction. Consider a planet known as HD 189733b. From our distant vantage point, it is a beautiful, deep cobalt blue, a shade remarkably similar to our own Earth. But this serene colour belies a world of unimaginable atmospheric fury. This is a hot Jupiter, a gas giant orbiting so close to its star that its atmosphere is heated to over 1000 degrees Celsius. Its enchanting blue colour does not come from oceans, but from a hazy, high-altitude atmosphere filled with microscopic particles of silicate, the primary component of glass, and this world is lashed by winds of incredible speed, moving at over 8,700 kilometers per hour, more than 7 times the speed of sound. These winds whip the molten glass particles through the atmosphere, creating a storm of sideways, razor-sharp rain. It is a strange and beautiful thought. A world that from a distance looks like a calm blue marble is in fact a place where the air itself is made of daggers, a surreal landscape of shimmering, deadly beauty. In the deep, dark and cold outer reaches of our own solar system, and presumably in the hearts of similar icy giant exoplanets, an even more wondrous form of precipitation may be falling. On planets like Uranus and Neptune, the atmosphere is rich in methane, a molecule made of carbon and hydrogen. Deep inside these planets, thousands of kilometers below the cloud tops, the pressure becomes immense, millions of times greater than the atmospheric pressure on Earth. Under this colossal weight, the methane molecules are broken apart, and the carbon atoms are squeezed so intensely that they crystallize, forming solid diamonds. These newly formed diamonds, possibly kilometers in diameter, would then be heavier than their surroundings and would slowly begin to rain down through the planet's deep, slushy, fluid interior. Imagine a journey into the heart of such a world, descending through the cold upper atmosphere into a dark, dense realm where, for thousands of miles, you would be surrounded by a slow, silent, and glittering rain of diamonds, all drifting down towards a solid, growing layer of diamond that may encircle the planet's rocky core. It transforms these distant, cold worlds into cosmic treasure chests, where a substance we consider the rarest and most precious on Earth falls as a common, quiet rain. Many of the planets we have discovered orbit small, cool, red dwarf stars, which are the most common type of star in our galaxy. Because these stars are so dim, a planet must orbit very close to them to be warm enough for liquid water. This close proximity means these worlds are likely to be tidally locked, with one side of the planet perpetually facing the star and the other side perpetually facing away. This creates a world of two extreme and permanent climates. A day side, where the star hangs motionless in the sky, baked in constant scorching light, and a night side, a hemisphere locked in an eternal, frozen darkness. On such a world, the most promising place for life to exist would be in the terminator zone, the narrow ring of twilight that separates the two hemispheres. In this gentle, temperate band, the star would always hang low on the horizon, creating a state of perpetual dawn or dusk. It is a beautiful, serene image. A world where life might thrive not under a moving sun, but in a calm and stable ribbon of eternal twilight, a protected haven between a realm of fire and a realm of ice. And we can begin to glimpse these incredible details because we have learned how to taste the air of these distant worlds. When a planet with an atmosphere transits, or passes in front of, its parent star, a tiny fraction of the starlight shines through that atmosphere before it reaches our telescopes. Just as the lines in a star's spectrum tell us what the star is made of, the light that passes through a planet's atmosphere picks up the chemical fingerprints of the gases that are present there. By analyzing the subtle changes in the starlight during a transit, we can identify molecules like water vapor, methane, sodium, or carbon dioxide. It is an astonishing feat of remote sensing. We can begin to know the chemical composition of the air on a planet that is trillions of kilometers away. And when we find the signature of water vapor in the atmosphere of a rocky planet in the habitable zone, it is a moment of profound and hopeful connection. A tiny clue that we may be looking at a world that holds the same precious ingredients for life that make our own planet so special. It is a way of reaching out across the void and, in the language of light, finding a beautiful hint of the familiar. And the fact that we can deduce the existence of diamond rain or the chemistry of an alien atmosphere from a few faint photons of light is a testament to one of the deepest and most beautiful mysteries of all. The universe, for all its wild creativity, seems to be written in a language we can understand, the silent, elegant, and universal language of mathematics. It is what the physicist Eugene Wigner called the unreasonable effectiveness of mathematics in describing the natural world. Why should the abstract, logical constructions of the human mind so perfectly mirror the fundamental workings of the cosmos? It is a profound question, but the evidence for this connection is everywhere. We find certain mathematical constants appearing in the most unexpected places. The number pi, which we learn as the ratio of a circle's circumference to its diameter, appears not only in geometry, but also in probability theory, and most surprisingly, it is woven into Einstein's field equations of general relativity, the very equations that describe the curvature of space-time and the force of gravity. There seems to be a deep and fundamental link between the geometry of a simple circle and the geometry of the entire universe, as if reality itself is built upon a foundation of pure and elegant mathematical relationships. This deep connection is most beautifully demonstrated by the predictive power of our mathematical theories. Time and time again in the history of science, a physicist or a mathematician, working with only thought, logic, and the relationships of numbers and symbols, has written down an equation that has predicted some new and unseen aspect of reality. In the 1930s, the physicist Paul Dirac formulated a beautiful equation describing the behavior of electrons, but the equation had two solutions, one for the electron and another that seemed to describe a particle with the same mass but a positive charge. A particle no one had ever seen. A few years later, this anti-electron, the positron, was discovered in cosmic ray experiments, precisely as Dirac's mathematics had predicted. In the same way, Einstein's equations for general relativity predicted the existence of gravitational waves and black holes nearly a century before we had the technology to confirm they were real. It is as if these mathematical structures are not something we invent, but something we discover, a pre-existing logic that the universe has been following all along. We are slowly, patiently, learning to read the source code of reality. At the heart of our most fundamental physical laws lies the beautiful and powerful concept of symmetry. In physics, a symmetry means that when you change something, something else stays the same. The most profound of these symmetries are connected to the conservation laws that govern our universe. For example, the law of conservation of energy, the rule that energy cannot be created or destroyed, only changed in form, is a direct mathematical consequence of a single, simple symmetry. The laws of physics do not change over time. Because the rules are the same today as they were yesterday and will be tomorrow, energy must be conserved. The law of conservation of momentum is similarly a result of the fact that the laws of physics are the same everywhere in space. These are not just arbitrary rules, they are the deep and harmonious consequences of a perfectly balanced and symmetrical underlying structure. The universe is not a chaotic and random place. It is a place of profound order, stability, and elegance, an elegance that is born from the perfect symmetries woven into its mathematical fabric. And this mathematical elegance is not just confined to the grand laws of physics. It is visible all around us in the intricate patterns of the natural world. In the 1970s, the mathematician Benoit Mandelbrot began to explore the world of fractals. Complex, infinitely detailed patterns that are created by repeating a simple mathematical rule over and over again. And he found that these fractal patterns are everywhere in nature. The branching of a tree is a fractal. The intricate structure of a snowflake is a fractal. The jagged, detailed pattern of a coastline, the forking of a lightning bolt, and the delicate branching of the veins in a leaf all follow these same principles of repeating self-similar mathematical rules. This reveals a profound unity in the creative processes of the universe. The same kinds of mathematical logic that can generate the complex structure of the cosmic web of galaxies on the larger scales also generate the delicate and beautiful forms of our own natural world on the smallest scales. Mathematics is the silent, invisible skeleton upon which the breathtaking, living, and ever-surprising body of the universe is built. This elegant, mathematical order provides the timeless stage upon which the universe plays out its story. And yet, our own experience of this story is anything but timeless. We feel it as a constant, flowing river, moving inexorably from a fixed past, through a fleeting present, and into an open future. This profound and universal feeling, the arrow of time, is one of the deepest and most personal mysteries of the cosmos. A mystery whose answer lies not in the mechanics of clocks or the motion of planets, but in a fundamental law of the universe that governs order and disorder. This is the second law of thermodynamics, and it states that in any isolated system, a quality known as entropy, a measure of disorder or randomness, will tend to increase over time. Imagine a perfect, new deck of cards, ordered by suit and number. This is a state of very low entropy, a state of high order. Now, if you shuffle that deck, you will randomize the cards, putting them into a state of high entropy or high disorder. It is very easy to go from the ordered state to the disordered state with a few simple shuffles. But it is almost impossibly difficult to go from the shuffled, disordered state back to the perfectly ordered state just by shuffling more. There are countless ways for the cards to be disordered, but only one way for them to be perfectly ordered. The universe is the same. It naturally moves from states of order to states of disorder, simply because there are vastly more ways to be disordered. This natural tendency towards disorder is the very thing that gives time its direction. The reason we experience time as a one-way street, the reason a glass that shatters on the floor never spontaneously reassembles itself, is because the shattered state has a much, much higher entropy than the whole state. The universe is simply moving into a more probable arrangement of its parts. The arrow of time is, in essence, the arrow of increasing entropy. We remember the past and not the future, because the past had lower entropy than the present. The flow of time that we feel is our own perception of this grand, cosmic unfolding, this slow, inexorable journey from a more ordered state to a less ordered one. Every process of change, from the cream dissolving in your coffee, to a star burning its fuel, to a sandcastle crumbling on the beach, is a small step along this universal path of increasing entropy. It is the great underlying current of the cosmos, a one-way flow that allows for cause and effect, for memory, and for the unfolding of a coherent story of the universe. This brings us to one of the most profound mysteries in all of cosmology. If the universe is always moving towards a state of greater disorder, then it must have begun in a state of incredible, almost perfect, order. The Big Bang, which we often imagine as a chaotic and fiery explosion, was in fact a state of remarkably low entropy. All the energy and matter in the nascent universe was arranged in an incredibly smooth, uniform, and highly ordered configuration. This initial, improbable state of perfection is the ultimate source of all the order and complexity we see around us today. It is like the universe was handed a perfectly ordered deck of cards at the very beginning of time. Ever since, it has been shuffling, and in that process of shuffling, all the intricate and beautiful structures we see, galaxies, stars, planets, and life, have been able to form as temporary pockets of order in a universe that is, on the whole, becoming more random. The existence of an arrow of time, the very fact that the universe has a history, is a direct consequence of this mysterious and beautiful gift of initial order. We are living in the long, graceful aftermath of a perfect beginning. And this grand, thermodynamic arrow of time is intimately connected to our own, personal, psychological experience of time's passage. The very act of forming a memory in your brain is a physical process. It involves creating complex neural connections, a small island of new order within the intricate structure of your mind. But in order to create this pocket of order, your brain must expend energy, and this process, like all processes, is not perfectly efficient. It releases heat into your body and the surrounding environment, and this release of heat creates a net increase in the total entropy of the universe. So, the act of remembering the past is an entropy-creating process. Our minds, in the very way they construct our sense of identity and our personal history, are following the same fundamental cosmic law. The psychological arrow of time, our feeling of moving from a known past to an unknown future, is inextricably linked to the thermodynamic arrow of time. Our consciousness is carried along on the same universal current that guides the stars. Our fleeting thoughts and precious memories are part of the universe's grand, unfolding story of becoming. And to be carried along on this great, cosmic river of time, to witness its unfolding for even a moment, is to be given the gift of perspective. It is a chance to see our own world, our own concerns, not as the center of everything, but as a small and precious part of a much grander story, a realization most beautifully captured in a single, distant photograph of our home. In 1990, as the Voyager 1 spacecraft was leaving our solar system, on its way to the stars, it turned its camera around one last time at the request of the astronomer Carl Sagan and took a picture of Earth from a distance of 6 billion kilometers. From that immense distance, our planet appeared as a single, tiny point of light, less than a pixel in size, a pale blue dot suspended in a scattered ray of sunlight. As Sagan so beautifully wrote, "On this mote of dust is everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, all our joys and sufferings, all our triumphs and tragedies, all our history, unfolded right there, on a tiny, fragile stage, in the vast, cosmic arena." The image is a profound lesson in humility, a silent rebuke to our tendency to see ourselves as the center of the universe. This feeling of profound perspective is an experience shared by nearly every astronaut who has had the privilege of seeing our world from space. It has been given a name: the overview effect. It is a cognitive shift, a change in consciousness that comes from seeing the Earth not as a map of countries with borders, but as it truly is. A single, unified, living sphere, hanging in the blackness of the void. From orbit, the thin, delicate, and iridescent blue line of the atmosphere becomes visible, a fragile membrane that is the only thing separating the vibrant life of our world from the cold, empty vacuum of space. Astronauts speak of an overwhelming sense of the interconnectedness of all life, a feeling of unity with all of humanity, and a deep, intuitive understanding that we must work together to protect our only home. It is a perspective that dissolves conflict and highlights our shared destiny. It is the realization that we are not just citizens of a nation, but passengers and crew members on a beautiful blue and white spaceship, making its journey through the cosmos. This sense of our own precious contingency is reinforced by a philosophical idea known as the weak anthropic principle. It notes that the fundamental constants and laws of our universe seem to be exquisitely fine-tuned for the existence of life as we know it. If the force of gravity were slightly stronger, the universe would have collapsed back on itself long ago. If it were slightly weaker, galaxies and stars would never have formed. The principle states that this shouldn't be a surprise to us. We are, after all, observing the universe, so it must, by definition, have the properties that allow observers to exist. A fish, if it were a philosopher, might wonder at how perfectly its world is suited for life in water. But the very fact that it is here to wonder at all is contingent upon that watery environment. This idea is not an argument for our own importance, but for the opposite. It is a gentle reminder that our existence is the result of a long, improbable chain of cosmic circumstances. It fosters a sense of gratitude and wonder that the universe we find ourselves in is one that allows for the emergence of consciousness. A universe that can, through us, begin to contemplate its own magnificent existence. The pale blue dot image and the overview effect also give us a visceral feeling for the immense, isolating emptiness of space. We often struggle to comprehend cosmic distances, but simple analogies can help. If you were to shrink the Earth down to the size of a single peppercorn, the Moon, on this scale, would be a tiny grain of sand about 4 inches away. The Sun would be a 4-inch wide ball about 40 feet away. And on this same scale, the very nearest star to our solar system, Proxima Centauri, would be another peppercorn located over 200 miles away. We live on a tiny, vibrant, and beautiful oasis in what is, for all practical purposes, an incomprehensibly vast cosmic desert. This profound isolation should not inspire fear, but connection. It tells us that this world, this pale blue dot, is everything. It is our only home, our only sanctuary, and our shared responsibility. This cosmic perspective, this view from a great distance, is a source of profound peace, a quiet call to cherish our world and each other more deeply, as we are all we have, together, on this tiny, brilliant jewel in the great, silent emptiness. This profound sense of our world as a lone sanctuary in the vast, silent emptiness naturally gives rise to one of the most compelling questions we have ever asked. Are we truly alone? We have turned our telescopes to the heavens, not just to see, but to listen, to search for any sign, any echo of another voice in the great cosmic silence. This search is set against the backdrop of a deep and unsettling mystery known as the Fermi paradox. The logic is simple and powerful. Our galaxy, the Milky Way, contains hundreds of billions of stars. We now know that planets are common, and a significant fraction of those stars likely host Earth-like planets in their habitable zones. Our galaxy is also very old, about 13.5 billion years old, giving life plenty of time to arise and evolve. Given all this, it seems statistically probable that intelligent, technological civilizations should have arisen many times throughout our galaxy's history. If even one of those civilizations had developed interstellar travel, even at very slow speeds, they could have colonized the entire galaxy in just a few million years, a mere blink of an eye in cosmic time. And yet, when we look and listen, we find nothing. No signals, no artifacts, no evidence of any kind. The universe is profoundly, resoundingly quiet. The paradox is this gaping contradiction between the high probability for alien life and the complete lack of any evidence for it. It is summed up in the simple, haunting question first asked by the physicist Enrico Fermi: where is everybody? To give this wondering a more formal structure, astronomers like Frank Drake developed a probabilistic tool known as the Drake equation. The equation is a long chain of multiplications, a series of terms that, when multiplied together, give an estimate for the number of detectable civilizations in our galaxy. It begins with known quantities, like the rate of star formation, and then moves into factors that we are beginning to understand, like the fraction of stars that have planets. But then, the equation ventures into the great unknowns. The fraction of those planets on which life actually arises, the fraction of that life which evolves intelligence, the fraction of intelligent life that develops detectable technology, and finally, the most poignant and uncertain variable of all, the average length of time a civilization survives and remains detectable. The Drake equation is not really meant to produce a definitive number. Rather, it is a beautiful, mathematical summary of our own ignorance. It is a structured conversation about hope and uncertainty, a way of organizing our questions about our place in the cosmos. It reminds us that the silence of the universe is not necessarily an answer, but rather the result of a series of profound and as yet unsolved mysteries. One of the most compelling and contemplative potential solutions to the Fermi paradox is the idea of the Great Filter. This is the hypothesis that there is some step in the long evolutionary path from simple life to a galaxy-spanning civilization that is incredibly difficult or improbable, a barrier that almost nothing can get past. The profound question for humanity is, where is this filter in our own timeline? Is it behind us? Perhaps the initial spark of life from non-living chemistry is an almost impossibly rare event. Or perhaps the leap from simple single-celled organisms to complex multicellular life like plants and animals is the great barrier. If the filter is in our past, then we may be one of the very first, or even the only, intelligent species in our galaxy. A lonely but incredibly precious dawn of consciousness in a vast and sleeping universe. The other, more sobering possibility is that the great filter lies ahead of us. Perhaps it is a natural tendency for all intelligent civilizations to eventually destroy themselves through nuclear war, environmental collapse, or some unforeseen consequence of their own technology. In this case, the silence of the universe is not a mystery, but a warning, a quiet, cosmic whisper, advising us to tread with wisdom and with care. In the face of this quiet, humanity continues its patient search. At various places around the world, enormous radio telescopes, great sensitive dishes upturned to the heavens, are engaged in the search for extraterrestrial intelligence, or SETI. They are the ears of our planet, listening intently to the faint cosmic static that washes over us from all directions, sifting through the natural noise of pulsars, quasars, and background radiation for any single, faint signal that is ordered, complex, and clearly artificial. To date, all they have heard is the natural, beautiful symphony of the cosmos. The project is an act of profound and persistent optimism, a testament to our deep-seated curiosity and our longing for connection. The Great Silence, as it is sometimes called, is not a sign of failure, but rather, it is the canvas upon which our own world's existence is painted. It is a peaceful, natural quiet that makes the vibrant, chaotic, and beautiful chorus of life on our own small planet stand out in magnificent, solitary relief. And so, in the face of this profound cosmic silence, we turn our gaze back from the distant stars to the vibrant, living world beneath our feet. And here we discover that if life is rare in the universe, it is also astonishingly resilient, a tenacious and creative force that has conquered every conceivable niche on our planet, thriving in places we once thought utterly uninhabitable. We have discovered a whole class of organisms known as extremophiles, lovers of extreme conditions, who make their homes in environments that would be instantly lethal to humans. There are bacteria that thrive in the boiling water of geothermal hot springs, algae that bloom in the hypersaline waters of isolated salt lakes, and microbes that live deep within the Earth's crust, miles underground, surviving without any light or oxygen. We have found fungi growing in the highly radioactive, cooling pools of the Chernobyl nuclear reactor, and vast colonies of bacteria living in the frozen, dry valleys of Antarctica, one of the most Mars-like environments on Earth. Life is not a delicate flower, blooming only in the most gentle and perfect of gardens. It is a powerful, adaptable, and stubborn force that, once it takes hold, seems capable of pushing its way into every available corner of a world. Perhaps the most profound discovery in this realm came in the 1970s, with the exploration of the deep ocean floor. In the crushing darkness and immense pressure of the abyss, miles below the surface, scientists found entire ecosystems thriving around hydrothermal vents, great volcanic chimneys spewing superheated, mineral-rich water from beneath the Earth's crust. Here, with absolutely no sunlight to power photosynthesis, life has found another way. The foundation of this ecosystem is a process called chemosynthesis. Bacteria have evolved to derive their energy not from light, but from the chemical reactions of the hydrogen sulfide pouring out of the vents. These bacteria, in turn, form the base of a rich and complex food web, supporting strange and wonderful creatures like giant tube worms with blood-red plumes, blind white crabs, and ghostly fish that have never known the sun. This discovery was a revolution in our understanding of biology. It proved that life does not require sunlight, only a source of liquid water and a source of energy. This vastly expands the number of possible habitats for life in the universe, suggesting that life could exist on worlds far from their stars, perhaps in the hidden, subsurface oceans of icy moons like Europa or Enceladus, warmed by their own internal geothermal heat. This incredible resilience of life has also given new life to an old idea known as the panspermia hypothesis. This is the theory that life, or at least its fundamental organic building blocks, may not have originated on Earth, but could have been delivered here from space, perhaps traveling on meteorites or comets. We know that rocks can be blasted off the surface of planets like Mars by asteroid impacts, and that these rocks can then travel through the solar system and eventually land on Earth. We have found Martian meteorites on our planet. If there were microbes living within such a rock, it is conceivable that they could survive the journey through space, shielded from radiation and the cold within the stone, and then seed life on a new world. This idea frames life not as a series of isolated, independent events on different planets, but as a potentially interconnected, galactic phenomenon. It turns the rocky debris of the cosmos into potential arcs, carrying the seeds of life from one world to another, a slow, patient, and natural process of interstellar propagation. No single organism embodies life's incredible toughness more than a microscopic creature, affectionately known as the water bear, or tardigrade. These tiny, eight-legged invertebrates are, for all practical purposes, nearly indestructible. When faced with extreme environmental stress, they can enter a state of suspended animation called cryptobiosis, purging their bodies of almost all their water and effectively shutting down their metabolism. In this state, they can survive being frozen in liquid helium to temperatures just above absolute zero, being boiled at over 150 degrees Celsius, being subjected to pressures 6 times greater than those at the bottom of the deepest ocean, and receiving doses of radiation that would be hundreds of times lethal to a human. Most remarkably, in 2007, tardigrades became the first animal to survive direct exposure to the vacuum and lethal radiation of outer space. This tiny, humble creature is a symbol of life's unyielding will to persist. It is a living testament to the fact that life, in its essence, is an incredibly stubborn and resilient force, perhaps even stubborn enough to survive the great silence of the cosmos. This relentless, creative force of life, in its long journey of evolution, has produced its most mysterious and beautiful creation of all. A mind that can be aware of itself, and a consciousness that can contemplate the universe that created it. We turn now from the universe of stars and galaxies to the equally vast and uncharted cosmos that lies within each of us, a realm governed by laws that are just as profound and perhaps even more perplexing. At the very foundation of the physical world that gives rise to our thoughts, we find the strange and wonderful principles of quantum mechanics. Consider the famous double-slit experiment. If you fire a single particle, like an electron, at a barrier with 2 slits in it, it behaves in a way that defies all common sense. If you are not watching, the electron acts like a wave, passing through both slits simultaneously and creating an interference pattern on the screen behind it. But the very moment you set up a detector to observe which slit the electron goes through, its behavior changes. It abandons its wave-like nature and acts like a proper particle, choosing one definite path through one definite slit. The very act of observation, of measurement, seems to collapse a world of possibilities into a single, concrete reality. This suggests a deep, participatory relationship between the observer and the observed, a gentle hint that reality, at its most fundamental level, is not a fixed and solid thing, but a shimmering sea of potential, waiting for an interaction to call it into being. This deep, quantum connection extends across the entire universe in a phenomenon Albert Einstein famously called spooky action at a distance. It is now known as quantum entanglement. It is possible to create two particles, like two photons of light, in such a way that they are intrinsically linked, their fates intertwined, no matter how far apart they become. They may have a property, like spin, that is always opposite. If one is measured to be spinning up, the other will instantly be found to be spinning down, and vice versa. This connection is instantaneous, faster than the speed of light, whether the particles are in the same room or on opposite sides of the galaxy. It is not that they are sending secret signals to one another. Rather, it is that they are not truly separate entities. They are two parts of a single, unified quantum system, a single reality that happens to be in two different places. It is a profound and beautiful whisper of a deep, hidden interconnectedness in the fabric of the cosmos, a silent, invisible thread that binds the universe together in a way that we are only just beginning to comprehend. And from this strange quantum foundation, built from atoms forged in stars, emerges the greatest of all mysteries, consciousness itself. We understand, in broad strokes, how the brain works as a physical machine, an intricate network of neurons firing electrical signals. But we have no idea how this physical process gives rise to subjective, qualitative experience. Why does the firing of certain neurons create the feeling of seeing the color red, or the experience of hearing a beautiful melody, or the gentle, peaceful feeling of drifting off to sleep? This is the hard problem of consciousness. It is, perhaps, a mystery we are not meant to solve, but to simply experience. Consciousness may be the universe's way of becoming aware of itself. All of the cosmic evolution, from the Big Bang to the formation of galaxies and the slow blossoming of life, has culminated in this. A part of the universe that can look back upon the whole and feel a sense of wonder and of awe. You are not a separate observer looking at the universe from the outside. You are the universe, observing itself from within. You are stardust that has come alive, and through your eyes, the cosmos is finally able to witness its own beauty. This inner universe of the mind is every bit as vast as the one outside. The human brain contains roughly 86 billion neurons, a number that is comparable to the number of stars in our Milky Way galaxy. But the true complexity lies in the connections between them. Each neuron can form thousands of connections, or synapses, with other neurons, creating a network of such staggering complexity that the number of possible pathways through the brain is greater than the number of atoms in the known universe. This is not just a sterile, computational network. It is the living, dynamic, and ever-changing tapestry of your entire life. Every memory, every dream, every thought, every feeling. As you lie here now, preparing for sleep, you can allow yourself to drift into this inner cosmos, a space of infinite peace and potential, a universe of your own making that is just as wondrous as the one filled with stars. The greatest journey, in the end, is not to distant planets, but the quiet, inward journey to the calm and silent center of your own awareness. And in this quiet, inner cosmos, where the universe reflects upon itself, we can find a deep and peaceful acceptance of our own small but precious place in the grand story. We are a brief and beautiful moment, a fleeting opportunity to witness the wonder of it all. To truly feel this, it can be helpful to visualize the entire history of the universe on a more human scale, using the cosmic calendar, an idea popularized by Carl Sagan. If we compress the entire 13.8 billion year lifespan of the universe into a single calendar year, then the Big Bang happens at the first instant of January 1st. On this scale, our own Milky Way galaxy does not form until early May. Our solar system and our Earth are latecomers, appearing only in early September. The first simple, single-celled life arises on Earth around late September. For all of October and November, life remains simple. The first multicellular organisms, our distant ancestors, don't appear until mid-December. The dinosaurs roam the Earth during Christmas week and are gone by December 26. And what of us? All of recorded human history, every king and queen, every war and every peace, every book, and every song takes place in the last 14 seconds of December 31st. The life of a single human being is but a fraction of a second in the cosmic year. This perspective is not meant to make us feel insignificant, but rather to free us. Our lives are a brief, luminous flash in an immense and ancient story, a gift of a single, precious moment. And this grand story, like all stories, will one day have an ending. Just as the universe had a beginning, it will have a final state. The most likely scenario, based on our current understanding of dark energy, is a future known as the Big Freeze, or the heat death of the universe. In the far, far distant future, trillions upon trillions of years from now, the relentless expansion of the universe will have pushed all the galaxies so far apart that the night sky of any remaining world will be completely dark and empty. The fuel for new stars will be exhausted, and one by one, the last stars will flicker and die, becoming cold, dark remnants. Even the black holes themselves will slowly evaporate away through Hawking radiation, until nothing is left but a diffuse, cold, and uniform sea of elementary particles. The universe will have reached a state of maximum entropy, a final, perfect equilibrium. This is not a violent or tragic end, but a final, peaceful rest. It is the universe, after its long and brilliant life, finally exhaling and coming to a state of perfect, unending stillness and silence. To contemplate these vast spans of time, our own fleeting existence, and the ultimate, quiet fate of the universe can be a source of profound peace if we approach it with a sense of acceptance. The ancient Stoic philosophers had a concept for this, which they called amor fati, the love of one's fate. It is the practice of embracing everything that happens in life as a necessary and beautiful part of the whole. It is to accept our own impermanence, not with sadness, but with gratitude. Our lives are not a mistake or an accident in an unfeeling universe. We are a natural and integral part of its unfolding story. To love our fate is to understand that our brief time here is what makes our experience so precious. The beauty of a sunset is enhanced by the knowledge that it will not last forever. Our own fleeting consciousness is an opportunity, a brief window through which to witness the majesty of the cosmos, to feel love, to learn, and to experience a sense of wonder. That is a gift of incomprehensible value. And so, we come to the end of our journey, back to where we began, with the comforting knowledge that we are a part of a great, unbroken cycle. Your consciousness is a temporary and beautiful pattern, but the stardust of which you are made is eternal. The atoms in your body, forged in the hearts of long-dead stars, will one day be returned to the earth and to the cosmos. They will continue on their endless journey, becoming part of the soil, a blade of grass, a cloud in the sky. And perhaps, in the far-flung future, on some distant world yet to be born, they will be gathered up once more to become part of a new star, a new planet, and maybe, just maybe, a new form of life that will look up at its own night sky and wonder. Your story does not truly end. You are, and you will always be, a part of the universe. Thank you for joining me on this gentle journey through the stars and through ourselves. I hope these stories have brought you a sense of peace, wonder, and calm. May your mind be still and your body be restful as you now drift into a deep and rejuvenating sleep. If you have enjoyed our time together, please consider leaving a kind comment to share your experience and subscribe for more quiet stories to help you rest. Sleep well.